Dear students, let's talk a little bit about the principles of optics. We are talking about glasses, lenses, and also with light. How do lenses interact with light, for example? But to start, let's start with the glass slab. So this is a slab which is not in a form of lens. It's not a converging lens or diverging lens. It's just a flat glass. And if we use our ray model or wave model using these four rays, as you can see now we have light that is going through the glass slab, but because the glass is actually at 90 degrees, the surface of the glass is at 90 degrees with the incoming beam of light, you can see that it's totally straight and getting out of the glass. That is what happens when we have a structure which is completely flat like this. So light comes, it goes through the glass, and especially because this is at 90 degrees with the surface, it goes straight through the glass. Now, what if we use a converging lens and diverging lens? Let's take this away for now. And let me use a converging lens, for example. So this is an example of a converging lens. Let me turn it around so it can work as we want. And let me take it to the light path. Now you see what is happening. This is a convex or converging lens. As you can see, you see one side is flat, one side is curved, converging lens. You can see all these rays of light are actually focused at this particular point here. So with a converging lens, we get the beams or rays of light actually converged to a certain focal point according to the lens. So this is our focal point here, and you can see that a converging lens does exactly that. Take this away and let's talk about a diverging lens, for example. What happens when we have a diverging lens? I will turn this diverging lens around and then put it in the path that light goes through. See what happens. If we have a diverging lens, make it straight a little bit. Yeah, if we have a diverging lens, this is what happens. So the rays of light are now diverged. You see, the previous one, they were converged into the same point, or a single point. But now they actually diverged into various different directions, and they are not going to meet anymore because the lens we are using is a diverging lens. So when you hear about light and optics, the most important thing is that how light, like the laser light, for example, or LED light, interacts with these different types of lenses. Dear students, in the past episode we discussed about the flat glass slab, and especially when you have the ray of light which is at 90 degrees, or the beam of light that is at 90 degrees with the surface. What if it's not at 90 degrees with the surface? Let's try to turn this so that it is at a certain angle with the surface. Look at what happens here. So as I'm turning this around, as you can see, as I'm turning this around, you see that light is now, because the incident ray is not, or the incident beam is not at 90 degrees with the surface, the light is now refracted within the glass and then emerges outside. So depending on how the nature of the structure and the angle of incidence, it will change the shape of the beam that comes outside. If, for example, I do some maneuver, like for example, see what happens now. So if you have different structures, you can maneuver these different structures in different ways and produce different effects of light, as you can see here. See now these 2 or 3 are on top and 2 are on the bottom side. So depending on the nature of the surface, incoming angle, and actually the orientation of the glass slab that you have, you can actually transform light into different parts and cause it to actually have different diverse effects. Thank you very much for listening. Dear students, welcome, and let's test a very simple but very important concept called total internal reflection. Here we have light source, which is our laser light source, and if I turn this on, you can see what is happening. So this is like a glass. It's a long glass slab, and as you can see, when these are arranged in order and you have this kind of a slab, and you have a laser light which is actually directed in a certain angle, here, as you can see, this is a particular angle, so you cannot, if I just put it at any angle, you see, it doesn't work. It might not achieve what I want. So you need to actually inject the laser light at a certain angle, which will enable light to be confined inside the glass. So as you can see here, our light gets in here, it's injected, it bends at this corner, bends at the second corner, and it continues going. This means if we had this block continuing, you will receive the same bending all across. It will be going and bending back and forth. It will be just bending back and forth within the glass slab. This is the principle that is called total internal reflection. But when you manage to inject light at a certain angle into the slab or glass, you can see that now here, what we have is that light is completely reflected within the glass, and it can continue traveling for a very long distance within the glass slab. And this is why, this is what takes place in fiber optics cables. As you hear about fiber optics communication, in Swahili we say mkongo wa taifa wa mawasiliano, which is used a lot in telecommunication and high-speed internet. So this is how total internal reflection takes place in a simplistic way. Thank you.